Hey everyone, Nick here. If you caught my first video in this series, you already know we're tackling something massive, a 5-foot Triceratops. Today, I'm bringing you the follow-up you've been waiting for. We're diving into resizing and cutting the model in Luben, setting up the first group of prints, and walking through the complete workflow, from slicing settings to gluing parts and so much more. Now, I know the idea of managing this many prints might seem overwhelming. Trust me, it wasn't long ago when a project like this would have scared the living daylights out of me. That's why I'm walking you through every step of the process to help you avoid the same mistakes I made along the way. Many of the tutorials I share with you weren't available when I first started, and that's exactly why I created this channel, to fill the gap with high quality resources that help you confidently tackle projects like this. This video is packed with everything you need to make your large scale printing feel manageable. I'll share exciting techniques like optimizing settings in Bambu Studio, a visual workflow I developed to save time and filament, and a system to track your progress so that you stay organized and on budget. Plus, I'll show you the updated assembly sequence in Luben, thanks to the suggestions I made to the developer, making it easier than ever to follow. And if this project has you inspired, guess what? This incredible model is available for free on Colts 3D. I'll link it in the description below, so grab a cold one and let's get started on this Jurassic-sized adventure. The first thing we need to do is load our Triceratops skull into Bambu Studio. The reason I'm starting this project in Bambu Studio first is because, one, it makes it very easy to control the resizing of my model by a percentage or in millimeters. It also gives me a really good idea of how it compares to my build plate once I make my resize. Let's go ahead and first import both parts. I'll go ahead and add a second build plate for the mandible. Hit the add button here and load both the skull and the mandible into Bambu Studio. When loading both parts in, it will ask you if you want to import as a single object, just hit no. Next, I'll separate each model onto their own build plate and center them. Now once I resize the skull, it's going to be massive, so let's do that next. Select the Triceratops and click on Scale. Make sure that Uniform Scale is checked. The size that I'm shooting for this project is going to be 4 feet wide from frill edge to frill edge. So let's go ahead and resize the x-axis to 1225. That's just a bit over 4 feet. The reason I love resizing in Bambu Studio is now that it also gives me the percentage of what the resize is, and it's showing 491%. Now if I zoom out, you can just see the pure mass of this thing compared to the build plate. Alright, great, let's go ahead and resize the mandible to the exact same percentage. I'll go ahead and copy the scale number for now. Select the mandible and open up the scale tool. Paste in the scale amount into the x-axis. Now we have the model scaled and ready to be cut in Luben. Let's go ahead and export each model separately as a new file. Select the skull, right-click on it, and select Export as 1STL. I'm going to give it a name and add resized 491 so that I know it's been resized and how much. Let's do the same thing for the mandible. Select, right-click, hit Export as 1STL. Rename and hit Save. Next, let's go ahead and open up Luben and get these models cut. Once you have Luben open, we need to load the first model. I'm first going to start with the skull, so let's go ahead and click on the little folder icon here. Find your resized model and click Open. Next, we need to use the Cut tool. Go up to Mesh, then Cut. Hit Yes on the preceding tip window that opens up. Then click OK on using millimeters. First, you need to make sure your method is set to Modular Cut. You should have a window that looks pretty close to this. Since we already resized our model, you don't have to worry about that step. Under the 3D printer section, make sure you have your printer build size all set up. You can see I changed mine to 256 cubed to match my Bambu printers. Select Close Cut Yes, Natural Cut No, and Part Numbers to Yes if you want to include printed numbers on each of your parts. I definitely recommend this. Next is where we will decide on which type of connector we want to create for our cuts. I explained all of this in great detail in my previous video, Easy Way to Cut a Large Model. If you haven't watched that one yet, pause this video and watch that one first. For this project, I'm going to use the following settings. We're going to use the plug option, the design of prism, shape of square, and the number of 5, which is how many connectors Luben will create. The depth ratio of 2 and the tolerance of -0.3. I noticed that if I use a negative number of something like -1, it just gives me too loose of a fit. Go ahead and hit Cut. Luben will ask you where you want to put your cut files. Hit the select folder and Luben will run through the cut process and dump all your parts into that folder. Once it is done, you'll see an overview of everything. Looks like the skull is going to be 117 parts. Let's repeat that same process for the mandible. mandible came out to 15 parts. Perfect, we have a total of 132 parts. Before closing Luben, we have one more task to complete. This is going to give us a kind of roadmap for our prints. I'm going to show you how you can easily track each of your prints using Bambu Studio. There will be a time when I literally print for an entire week straight, one part after another. So wouldn't it be nice to be able to visually see a display of our prints? Well, I figured out a way to do just that. The first thing we need to do is explode our model. Now this is going to be all preference, but for this project I exploded our Triceratops by pressing the E key on the keyboard 10 times. This expands all the parts. You can actually retract your explosion by pressing the R on the keyboard as well. This gave me good enough spacing so that I can clearly see each part number as well as having every part with a good amount of spacing. Once you're satisfied with how it looks, go up to File, then Export and select STL. This is going to save our Triceratops model just as you see it on the screen. I usually give it a name, exploded _ and then the name of your model. Make sure you do this for both the skull and the mandible. Alright, we're going to tuck these files away for just a little bit and we'll be back to them. Next we need to jump back into Bambu Studio and start importing our skull parts. Now when importing multiple models like this, I wish that Bambu Studio had the ability to put them in order when using the auto arrange feature, but it doesn't have that ability yet. So I just import 5 models at a time and add a bunch of build plates and put each model centered on its own. Let's go ahead and do that now. Alright, we now have 10 models imported on their own build plate. Let's go ahead and orient them. When models are cut like this, Bambu Studio has a much better idea of the best way to orient each model. I'm going to allow Bambu Studio to handle this for me. Hold Shift on the keyboard and select all the models, or you can use the Control A to select all the models at once. Hit the Auto Orient button right here. Now with that said, Bambu Studio does a great job most of the time, but it's still good practice to check each model quickly. As I check them, I'm also going to center each model on the build plate. Alright, great. Our first 10 prints are ready to go. The next thing I'm going to do is set up a print profile for this project. This will allow me to quickly select that particular profile and make sure that the entire model is printed exactly the same. To do that, I like to start with a system preset. I'm going to use the 0.2mm strength preset as my base. Let's go ahead and make some adjustments to the strength tab. The 6 wall loops is perfect for this project. What I want to adjust is going to be my sparse infill density. Before I do that, let's go ahead and slice part number 2 with the 25% infill. The print time looks like it's going to be around 13 hours with 500 grams of filament. Now if we adjust that infill to 18%, we get 456 grams of filament in 11 hours. I feel that 25% is just a bit overkill. I also don't want the Triceratops to weigh a ton either. I've printed large skulls using anywhere from 15 to 18% and the durability is just fine. We have a good amount of wall loops, so we should be just fine as far as integrity goes. Next, let's go ahead and enable supports. I'm going to use tree supports and make 3 adjustments. The top Z distance I'm going to adjust to 0.28. And the object XY distance to 0.4. I'm also going to adjust my top interface spacing down to 0.4 to give my support interface just a little bit more base. This is because I'm going to be adding a spacing with the top Z distance. I've had great results with these settings. Let's give this preset a name. Click on the Save Disk icon here. I'm going to remove everything in the name except for the 0.2mm, and I'm going to add Triceratops to identify the project, 6W to tell me how many walls, 18% for infill density, and last, support OP as a note that I optimize my support settings. Click OK. For this project, I'm using Polymaker's 5kg filament spools, which are perfect for large-scale prints just like this. With these jumbo-sized spools, I can focus on printing without the hassle of frequent filament swaps, saving time and ensuring consistent quality throughout the process. Polymaker filaments are known for their exceptional reliability and smooth performance, making them my go-to choice for everything from small projects to massive builds like this one. If you'd like to get some more information on their products, check out the link in the description below or go to polymaker.com. Now that we have started our long but rewarding journey into this project, let's go ahead and set up our visual tracker next. First, open a new Bambu Studio project. Then import your exploded model that we created earlier. Just ignore that error that you get in the bottom right corner. Now when we click on this STL, it selects the entire file. Let's go ahead and fix that first. Go up to Split All Parts right here and click it. Once that is done, switch over to Objects mode. Now you can see every individual part and have the ability to select them. Now before we move forward, I wanted to let you know that this process isn't 100% perfect. Sometimes you will get STL file numbers that don't match. By this I mean you'll have some objects that are marked number 20 in the menu over here on the left, but it's actually not the number 20. For this particular project, I noticed less than a handful of these discrepancies. You can fix this by manually renaming all of the individual parts the correct name. Alright, let's go ahead and give it a once-over look and do some spot checking to make sure that they're mostly named correctly. Now what I do next is add a filament to this project. Click this plus button right here, then give it a different color by clicking here. Let's go with green. The basics of this is to use the green filament and change the color for each part that you print so you know how much of your project has been completed. As a visual learner, this helps me see how much of the project is completed at a glance. I also use this color-coded approach to plan filament infill densities. Printing the entire model at 18% infill would be unnecessary. So this method allows me to strategically adjust densities to save time and filament. For example, the back of the skull where it will be mounted needs to be the strongest, so I've chosen 18% infill for that area. However, as the skull extends outward towards the nose, pressure starts to distribute across the structure. To reduce the weight and material use, I'm scaling back the infill to 12% for the internal sections and 10% for the outer parts. This not only saves on filament, but also helps alleviate potential overhang pressure. To map this out, I added yellow for 12% and orange for 10% to my visual plan. Once the plan is finalized, I transfer the details to my Google Sheet tracker, which I'll show you next. Here's a quick time lapse of me setting up my infill densities ahead of time. You're welcome to watch this part or fast forward through it. Remember, this is just a visual representation of my infill setup process, and these values are subject to change as I move through the project. I wanted to give you a quick tip. In this video, I'm using the right-click menu to switch filament colors, but if you click on the model in the menu on the left-hand side, you can switch filaments much quicker if you use the numbers on the keyboard. 1 for 1, 2 for 2, etc. The tracking sheet I use is nothing fancy, just a simple Google Sheet to keep track of the part details, filament usage, print time, and totals. I'll include a link below so you can make a copy if you'd like to use it for your own projects. As you can see, I'm currently at part number 80, and I've made note where I've adjusted the infill percentages for the front of the Triceratops to help reduce weight. So far, this project has used 45 rolls of filament and has taken over 1,100 hours of print time, which translates to 48 days of nonstop printing. It's been an ambitious undertaking, but the progress has been well worth it. After over a month of printing this project on all 4 of my Bambu printers, including sneaking in a few smaller parts on my Mini, this is what my office floor looks like. Today is the day I organize these pieces and make note of any missing parts. I already know one part is missing, as sometimes I jump ahead to keep a better rhythm going. This helps me time prints so one finishes when I'm available to start the next. Once I identify the missing parts, it's time to begin the assembly. Thanks to a recent Luben update, this process is now 10 times easier to follow. I worked directly with Luben's developer to suggest improvements, and they rolled out an update based on my feedback. Now the assembly file generates a numbered sequence that looks just like this, making it straightforward to follow. Since I'm starting the assembly before finishing all the prints, I simply use ChatGPT to adjust the list with a specific prompt. It automatically reorganizes the sequence so I can begin with part 1. Here's that prompt. Rearrange this assembly sequence of 3D printed parts in ascending order, starting with the lowest number. Short and simple. The obvious starting point for this build is parts 1 and 2. When assembling, I like to glue as many parts at the same time as I have clamps for. That's why I highly recommend purchasing at least 10 clamps. Sizes between 6 inches and 18 inches are ideal. And I'll include a link to the bundle I personally use below. One quick tip: avoid the cheapest clamps. They tend to loosen over time, or worse, unclamp themselves mid-process, which can ruin your day in a flash. Here's some footage of me clamping parts 1 and 2. For this, I'm using Gorilla Epoxy Glue, which I buy in bulk. I've noticed that some Amazon sellers like to charge more for the bulk option than for buying single packs, so keep an eye out. The link I've shared is the most cost-effective one I found. Using the glue is straightforward. First, remove the black mixing stick from the plunger handle. I use the same stick to apply a thin, even coat of epoxy to my parts. Mixing the right amount of epoxy can take a little bit of practice. At first, you might waste some glue, but trust me, you'll get it over time. My advice: start with small amounts, mixing only what you need. Use the black stick to mix the epoxy for about 20 seconds. That's all it takes. Oh, and yes, fair warning, it does have a strong smell. Trust me, my wife always knows when I'm gluing. When applying the glue, I like to start with the part that has the female connector end. This allows me to get a good amount of epoxy into the connector hole. A little goes a long way, so avoid applying a thick coat where the two surfaces meet. Thinner is better. It provides a stronger bond and reduces the risk of the parts detaching later. I also scrape away any excess epoxy from the edges to minimize oozing when clamping the parts together. Once the glue is applied evenly, it's time to clamp. Make sure to get as many corners as possible for a flat, secure connection. This is also a great opportunity to straighten or flatten corners that may have lifted during printing. Personally, I don't always use a brim while printing. Sometimes I forget, and sometimes I just don't bother. Small gaps can be easily hidden during post-processing anyways. One common challenge is alignment. The parts won't always line up perfectly, and that's okay. I used to stress over perfect alignment, but now I focus on getting it as close as possible and clamping it down. It's honestly much easier on your mental health to let go of perfection and just move forward. Here's some time-lapse footage of me gluing and clamping a few more of the parts together. Let me know in the comments below if this explanation was clear enough, or if you'd like to see more examples of how I glue and assemble these parts. Your feedback is always appreciated. Let's spend some time diving into the assembly process in Luben because it's nothing short of impressive. I have to tip my hat to the Luban developer for designing such an incredible algorithm. It truly simplifies assembling large-scale projects like our Triceratops. To walk us through the process, I came up with my own naming convention to separate each level of gluing parts. Hopefully this makes it much easier to follow. Level 1. Initial Model Cut. The process starts by cutting the model into pieces that fit your printer's build plate. Let's call these build plate size pieces, Level 1. For our Triceratops project, this results in 117 parts for the skull. Level 2. Gluing parts together. Next, we move to Level 2, where individual parts are paired and glued together. For example, Part 1 gets glued to Part 2. In the case of our Triceratops, there are around 50 of these pairs to complete the Level 2 skull assembly. Level 3. Pairing pairs. At Level 3, those glued pairs are joined with other pairs, or leftover single parts to form small groups. For example, Parts 1 and 2 get glued to Parts 3 and 4, creating a more substantial group. Level 4. Grouping small groups. Now at Level 4, these smaller groups are merged into larger groups. For example, Parts 1 through 4 get glued to Parts 5 through 6. At this stage, the pieces start forming bigger and more recognizable sections. Level 5. Building small sections. Level 5 is where those large groups combine to create small sections. For example, parts 1 through 6 join parts 7 through 13. By now you're working with assemblies made up of about a dozen individual parts. Level 6, forming large sections. At level 6, we start creating large sections. For example, parts 1 through 13 are glued to parts 14 through 23. Pay close attention to gaps at this stage. If needed, fill in spaces with additional epoxy and give those sections a final clamp to ensure a solid connection. Level 7, assembling extra large sections. In level 7, large sections are merged to form extra large sections. For instance, parts 1 through 23 join parts 24 through 33. By now, the model really starts to take shape. Be prepared to go through quite a bit of epoxy here. I've used at least 10 tubes by this stage. If any sections don't fit perfectly flush, fill in the gaps and clamp them down for one last bonding session. Level 8, joining extra large sections. Level 8 is all about connecting those extra large sections. This step gets you to the point where you've assembled two complete halves. Proper alignment during earlier steps pays off here, making the stage much easier. Level 9, completing the assembly. Finally, the two halves are assembled together to complete an entire assembly. However, you may want to keep them unglued for easier transportation or storage. Another option is to use magnets to hold the two halves together, offering flexibility if you ever need to move the model through a doorway or tight spaces. Now, I really hope that this demonstration helps you understand the assembly process. This would have tremendously helped my anxiety the first time I printed a large model, which is why I spent the time to tediously create this video for you. In the next sections of this video, I'll go over the issues that I've run into with this project, and lastly, I've included a ton of tips to help make your next project go as smoothly as possible. One issue I encountered during this project was forgetting to adjust the border clearance setting when cutting in Luben. The border clearance should have been set to 10 instead of 0. As a result, 3 parts ended up slightly exceeding the build plate size. If the border clearance had been correctly set to 10, then Luben would have automatically scaled these parts down to fit the build plate, completely avoiding this issue. While this wasn't a big enough problem to derail the project, it was still a hassle. I used Bambu Studio's built-in cut tool to cut the 3 parts into smaller sections, then glued them back together after they were printed. This oversight happened because I've never run into this issue before, but it's always a great reminder to double check your settings. I hope that this tip helps you save some frustration with your projects in the future. So the question is, does part orientation matter? The short answer, absolutely. Let's take part number 58 as our example. Here's how I originally printed it. Not my finest hour, I'll admit. I wasn't paying much attention when I sent this one to the printer, and as you can see, the result, not so good. The supports left the connection side a complete and utter mess. I even tried connecting it to its mate, hoping it would lay flush, but it just didn't work. To fix this, I reoriented the part and printed it the correct way. For this, I used a simple trick. I used a simple primitive cube, flattened it, and merged it with the part. This allowed me to lift it off the build plate and orient it precisely how I wanted. If you're curious about this technique, I go into great detail in another video, which I'll link here. This method has become a game changer for me, especially when printing dinosaur bones that don't have a flat surface. It consistently gives me the cleanest prints with minimal failures. As you can see, the second print using this method came out much cleaner. The connection side is perfectly flat and it mates seamlessly with its counterpart. So before sending your parts to the printer, always take a moment to consider their orientation. It can mean the difference between a successful print and having to start over. Here are some of my most valuable tips, hard-earned lessons that have made a huge difference in my own projects. I hope they help you streamline your workflow and bring your creations to life in the best way possible. Sharpie your prints. Number the prints on the front. Once you start gluing your parts together, the 3D printed numbers get covered and you could lose track of which part is which. Then you'll have to rely on the exploded model for everything, which is time consuming. Sharpie the number on the front of the print before gluing and you'll save a ton of time. Creating clamping surfaces with larger clamps. At some point, you'll run into a situation where you have no good spot to clamp your parts together. When this happens, don't hesitate to use a larger clamp to create a temporary clamping edge. By securing a large clamp in one direction, you provide a stable surface for additional clamps to grip onto. I had to use this technique multiple times during this project, and it worked like a charm. Start gluing as you print. Don't wait until every part is printed. This approach reduces the number of clamps needed and makes the entire assembly process much more smooth. For this project, I held off until I had nearly 80 parts printed to showcase the sheer scale, but gluing and clamping along the way will save you time and keep your workspace more manageable. Plus, your significant other will probably appreciate the less chaos. Adding a mounting hole before cutting in Luben. This is definitely one idea I wish I had before starting this project. My original plan was to use a motor dolly to display the Triceratops skull. But before cutting the model in Luben, I should have taken the extra step to carve out a large cavern in the rear of the skull using Bambu Studio. This would have made it much easier to fabricate a metal insert, allowing the skull to float for a cleaner, more seamless display. Instead, I'm now shifting to a different approach, building a flat rolling dolly with vertical arms to support the skull and mandible. And also, if you're planning to print a large statue, this approach can also allow you to add a steel pole insert to give your print more stability. If you're tackling a large-scale print like this, planning for mounting solutions or more stability ahead of time can make a finished product more custom. Looking back at the journey, it's incredible to see just how far this project has come. From mountains of filament to countless glued pieces, the Triceratops has truly taken shape, piece by piece, layer by layer. This isn't just about printing a giant skull. It's about pushing the limits of what's possible with 3D printing. It's about learning, problem solving, and creating something that simply wouldn't exist otherwise. There's still work to do, but seeing it all come together like this makes every hour, every filament change, and every clamp worth it. And this is why I love 3D printing. Taking an idea and turning it into something real. And if this project has inspired you, then I hope you'll tackle something ambitious too. I'm not done just yet. There's still finishing touches, painting, and a final display to complete. I also wanted to take a moment to thank Bambu Lab. Without their incredible printers, projects like this just wouldn't be possible. If you're interested in getting into 3D printing, I'll leave a link below to my recommended printers. Now I hope you enjoy these final shots of the build. It's been a long journey, challenging at times, but absolutely rewarding in the end. Thanks for watching. Again, my name is Nick, and as always, happy printing.